Hello and welcome to this series of lectures uh, on the reactions of period 3 elements. The next one is the reaction of the oxides of period 3 with water. So I'd like to draw your attention to what we've studied about the oxides earlier. We know that the oxides of the metals, sodium, magnesium, and aluminum, are ionic. Okay, silicon dioxide is covalent, but it is macromolecular covalent, similar to diamond in structure. The oxides of phosphorus and sulfide and sulfur, rather, okay, are simple covalent molecules. And if you look at them, you'll find that the ionic oxides are basic. Aluminum oxide is amphoteric, of course, while the non-metal covalent oxides are all acidic. So you can find that as you go from the left to the right, you start with basic oxides, turns to amphoteric. Remember, amphoteric is when a substance can act as either an acid or an alkali, depending on reaction conditions. And then it becomes acidic and ends up becoming pretty strongly acidic. The ionic oxides, they just react with water to form alkaline solutions. So sodium oxide gives you sodium hydroxide, magnesium oxide gives you magnesium hydroxide. pH of sodium hydroxide be around 13, 14. We know that it's a pretty strong alkali. Magnesium hydroxide, now magnesium hydroxide isn't very soluble in water. So when magnesium hydroxide dissolves, there's very little that dissolves. Most of it is seen as a white suspension, like a solid mixed with a liquid. Because it doesn't dissolve very well, it doesn't ionize very well, and hence you find that its pH is a little less. I mean, it's around 8 or 9. It's a pretty weak alkali. In fact, if you have acidity, a very common medicine that is given is called milk of magnesia, which contains magnesium hydroxide. So it's that weak. We cannot talk about the acid-based nature of silicon dioxide and aluminum oxide here because they do not dissolve in water. Okay, the oxides of phosphorus and sulfur react pretty vigorously with water to produce acidic solutions. P4O6, okay, phosphorus 3 oxide. It's called 3 oxide because the oxidation state of phosphorus in this compound is +3. Reacts with water to produce H3PO3, which is called as phosphorus acid or phosphoric 3 acid. The oxidation state of phosphorus doesn't change, which basically means it's just an acid-based reaction. It is not redox. While the phosphorus 5 oxide or phosphorus pentoxide reacts vigorously with water to produce phosphoric acid. Okay, pH around 3. They're not very strong acid, but not very weak either. So you have to say that it's somewhere around the ethanoic acid acidity mark, okay, for the phosphoric and phosphorus. Well, sulfur dioxide produces sulfurous acid, oxidation state of +4 on both sides. Sulfur trioxide, on the other hand, produces sulfuric acid. Sulfuric acid, we know, is pretty strong. Its pH is around 0 or 1. So we can say that as you go from the left to the right, they start as being basic, and the basic nature keeps decreasing. It turns to acidic. So similarly, you start from ionic, and the ionic nature decreases as you go across the period and turns into covalent. When it's like fully covalent, it becomes pretty strongly acidic. Okay, so that is what we understand from the reactions of the period 3 oxides with water.